Okay, year 10, welcome to the second lesson in P11, so P11B, where we start to look at dangers and uses of stuff. Okay, and yeah, we're still recording, so P11B, so please make sure you add the key points, and I'll try and make it very clear which ones the key points are, so you don't try and write down everything as we go. So I will open this lesson normally and talk about risk, because I think people always misjudge what the word risk means, and it means things in different contexts. Now, most people will say, oh, it's dangerous to do something, so therefore it has risk. Well, sometimes it's dangerous to do nothing. Just ask certain people what happens when you don't do homework I set you. See, there's risk on both sides. So risk is about looking at the bigger picture. So what happens if I do this? What happens if I don't do this? Can I do this in a better way that reduces risk? So I can mitigate that risk. So there's another lovely word for you, mitigation. It just means avoid, find a different path. But of course, the biggest risk is when you don't understand what happens when you don't do something. So that inaction can be a risk in its own right. Okay, so we would normally just develop that into key terms of risk. We'll leave that for the moment. To do is be able to describe what is meant by the term risk. So your own little explanation, if you could write that on your revision notes. I'm going to look at common everyday sources of static shocks. Now the word shocks might give it away. We would normally talk about this as bad. Okay, so there's times where we don't want static, and most of the explanations you've got to give me are bad shocks or bad transfers of static energy. But there are uses, okay, there are also good uses of static charges. So we need to know that there's a balance. So if we had a justified question, we'd be able to justify here's the good, here's the bad, and therefore we can make a decision based on all the information in front of us. Sources of static shock. So pause the video for 2 seconds. I'll stop talking for 5 seconds. Pause the video. Write down as many sources of static that we've talked about so far or that you can remember. So pause the video. I'll come back in 5 seconds. Okay, so if you come up with some ideas for static shock, I'll throw in some of my own. So we can talk about adhesion of feet on carpet, always a good one. We've obviously got things like woolen jumpers, anything with an insulator material, two insulators rubbing together, insulators rubbing, plastics, rubbers, latexes, anything that is an insulator rubbing together, or called static, and one that often gets overlooked, lightning. Okay, it's also a good version of static electricity. We have that huge build-up of. Okay, so this would be something I would talk about everyday sources of static shock, because most of what we deal with and we know about in everyday life is bad, and you might be talking about how unlucky someone might be, but if you want to talk about the bad, you also have to talk about the good. And if you want to understand the bad, you obviously need to know the difference between what is the difference between something that will annoy you or something that will kill you. And the difference was, so something like a shock from carpet will annoy you. It's certainly not going to kill you. And it's exactly the same thing with, how about we go lightning? Now, lightning isn't going to annoy you, it is going to kill you more than likely. But they're both static electricity. So what's the difference? Well, the difference is Q, or, as we hopefully can remember, charge. Okay, we're talking about huge differences in charge. We could have a Van de Graaff generator, which I appreciate you haven't seen in class, and we could have 2 million, capital M for million, volts on our Van de Graaff generator, which is about where I can usually get it up to if the air is dry enough, because if there's lots of moisture in the air, it discharges too easily. 2 million volts. Well, it's not going to kill me. Whereas I can have lightning that can be less than that. I could have lightning that would be 1 million volts. Oh, that's meant to be an M. 1 million volts. Well, the difference is that this lightning has huge amounts of charge, and our Van de Graaff generator, not much charge. So we have very, very high voltages, but very, very low currents. Yeah, so currents would be very, very small, minuscule. Unfortunately, if you're hit by lightning, you'd find out the hard way that the current is quite high. That's why most people who die from being struck by lightning have burn injuries, because there's a huge amount of current. Okay, so what does static electricity damage? Well, that's probably quite important to know, because most of you carry a mobile phone on you, and your mobile phone case is made out of metal, if you have an iPhone for example, and it will quite happily conduct the charge from static through your phone case into the electronic components. They don't like this. So you'll notice if we do the Van de Graaff generator, I will take my car keys and my phone out of my pocket, put them to the side, and if I get volunteers to come up, I'll ask you to do the same thing. Not because I'm particularly worried that you could, or that you will, I should say, discharge through your phone. It's because you could. And I won't take the risk because it does damage electronic components. Why my car keys? Well, my car keys usually have, most people's car keys now have a fob attached to them, electronic components that help the ignition system run on my car. I'd like to be able to drive home at the end of the day, so I don't take the risk. Like I said, not because it would definitely happen, it's because it could happen. So if you're ever working with electronics, you might see people wearing these wrist straps. And the idea of the wrist strap is that you would plug, I've got my pen up and running, just a bit. So you would plug your electronic board onto this clip. The idea being is then you don't get any jump of charge from your hand to, maybe you've got a very expensive chip on here, lots of legs for a chip. So you're avoiding that. So any current, any charge that is going to be transferred is going to go through this rather than onto some of the more fragile components. And some of these components run up into quite a lot of money. So I would suggest that if you're working in television, for example, and you're working on high definition cameras and you have to open them up, you probably want to wear one of these when you find some of the components inside are worth £40,000 or £50,000 each. Adds up very quickly. Okay, but apart from this, I'm just going to So apart from this, there's actually some very useful versions of static electricity where we actually want static electricity to occur. Now, obviously I won't get you to pair up, that might be a bit tricky, but I'll talk about the two diagrams left and right. And on the left hand side here, we've got our tractor spraying. Now, you would just see that as you're driving along or on the side of the field, spray going everywhere. But if you could make all this liquid static, and I'm drawing little pluses all over it, or negative, it wouldn't really matter, it would want to attract to what? Well, if I draw the ground here, and I draw my little plant, it's meant to be a plant, I know, okay, and I then spray it with lots of positively charged liquid, well, the first thing that gets it to the ground is the plant. So all of a sudden I've got all that liquid that I want on the plant just going on the plant. I'm not getting it falling on the ground where it has no benefit. So that's a really useful way. And in fact, the only farmer I've ever managed to get a straight answer out of this, who uses statically charged insect repellent, insecticide, because you want the insecticide all over the plant, not on the ground. He was telling me that he uses 20% of the amount. So a huge drop. That's an 80% saving. Where 80% of it used to end up on the ground or where it wasn't needed, it's a fifth of what he was paying for, and some of the insecticides are quite expensive. Take that across to the right-hand picture, so on picture number 2 here. Well, we want the paint to go where we want the paint to go, and we also want it to be really even. So if we statically charge all this spray, or negatively charge it, I should do a negatively charged one, and we can make the car body to earth. So we can attach a cable, we do it on the other side, I assume. If we attach a clip here that goes off to ground or earth, then all this static electricity, the paint is going to want to stick to the metalwork really quickly and really evenly. So we get a nice smooth paint job, which is obviously what they're trying to achieve. So again, these are two really good examples of useful static electricity. Okay, so I want to apologise to this. This was the English department made me write a poem about something to do with the lesson I was teaching from last year or the year before. So I won't make you do this, but I will ask you to make sure that you're adding on your key points to your revision document. It is only 3 lessons long, static electricity. There is a test, so let me just cross that out. There would be no P11 test, but there will be an end of week quiz this week. I don't want to let you off the hook too soon. End of week quiz, and once we finish P11, we're going to concentrate fully on the end of year test.